Hey guys and gals, we are going to start our new video, lesson 4.1. So we're into a new unit or a new chapter. We are doing lesson 4.1. We are doing powers of 10 with decimals. Cool thing is, if you've been with us the whole time, we have actually completed this lesson already. So this is hopefully going to be somewhat of a review and then somewhat of a maybe deeper understanding. Okay, so you should have your notebook with me, following along as I already titled it, Powers of 10 with Decimals. So first off, let's kind of recap. What is powers of 10? Let's just real quick, just 30 seconds, let's remember how to do this. So if I had 10 to the third power, remember, this is your base. That's what we call your base number. This is called your exponent. Remember, the big thing we always say is do not multiply these two. That's the biggest mistake because people see it. They think they know that this means something multiply, but they just want to multiply these two. You do not do that. What does this really mean? The exponent is telling us how many times to multiply the base. So it's really 10 times 10 times 10, which we know and we remember is 1,000, because when you multiply 10 times 10, you get 100. Bring down the other 10 times 10, that would be 1,000. But we also know the shortcut in knowing that the exponent is 3. When the base is 10, it also has 3 zeros on the end. And we know that works because every place value, remember our base 10, our place value system is made up on base 10. So every time you multiply by 10, remember you're shifting it, you're moving, you're pushing it up the place value chart. So since we're shifting it 3 times, he has to move 3 place value spots. Okay, so that is when you're multiplying by 10. But now we're going to do the powers of 10 with decimals. And to start, let's just kind of recap. What if we did this with whole numbers? And again, with whole numbers, we remember right away, hopefully, that when you multiply, that you can actually just multiply the base. In fact, I'm going to rewrite this to go 34 times 10 to the third power. So when I do this, I know I have 10 to the third power, which I wrote it out here. So I know I'm going to multiply by 1,000. Now, when we did this, we know that because I'm multiplying by a power of 10, I know that my number 34 is going to stay the same digits. If this was a 2, a 3, a 4, it won't. If this was a 2, a 3, a 4, it won't. But because it's multiplying by a 1, by a power of 10, it's going to stay the same digit. So I can just rewrite here. And then I know my exponent is a 3, which means I'm multiplying by 10 3 times. So that means 3 shifts up the place value chart. So really what I'm doing is I'm shifting them all up the place value chart. So I basically just took this 3 that was in the tens, and now look, he's now in the 10,000s. Okay, so again, that's kind of our trick that we've learned on how to do it. But now we have, what if it's 3.4? What if it's 3.4 times 10 to the third power? What do we do then? Well, we learned that we know we cannot put zeros in the end of decimals, so we cannot use this trick. This is a whole number trick, okay? This is understanding how whole numbers work. Now we have to understand how decimals work. And how this works is you cannot put zeros on the end. We know when you put zeros on the end, you do not change the value. That's called an equivalent decimal, okay? So what do we do then? Well, technically what we do is the same thing we do up here, except we don't see us doing it because it's so easy to do with adding the zeros. So what we're really going to do is we're really going to shift the place values. So again, we know we can do the same thing. We know since we're multiplying by a power of 10 that it's going to be the same digits, 3.4. Okay? The difference is what I'm going to show you up here, and then I'll show you the trick in a minute, is what we're really doing is this. Since I'm multiplying by 10 to the third, that means I have to shift these numbers up the place value chart 3 times. So he's in the ones. So I'm going to use this, and I'm going to keep this the same. He's the tens, the hundreds, and now the thousands. So there is where the new 3 is at. Okay? And again, keep in mind, I'm using all this as place value. So I'm using the tenths, the ones, the tens, the hundreds, the thousands. So there's the thousands. I shifted this 3 times. He moved 3 times, 10, 100, 1,000, okay? But I got to do the same thing to the 4, okay? They're a package deal. So now I'm going to do the same thing. He's got to move 3 times. 1, 2, 3, and now he goes here. Now, keep in mind, this is a place value spot. There's 2, there's 1 here, and there's 1 here that I need to make sure that I put zeros from, or 2, because if I don't, then it looks like I just have the number 34. So because I have 2 extra place value spots, I have to put the zeros there. Now, I could put 0.0 like this. That way it looks the same. I don't have to, though, because remember, when we don't have anything after the decimal, we don't have to have the decimal. Okay, so technically my answer is 3,400. Now, why did that happen? How did that work? I shifted the place value, the numbers, the digits up the place value chart. Now, I will be honest, that's really messy, and I don't love the way that looks. And a lot of times what people do is they forget the zeros. So people forget that this here is in line with this here. So then they forget, they forget the zero, and it's all messy. So I'm going to show you a trick, a tip on how to do this without. Now, it's the same kind of thing up here. You know how we add, let me do the air quotes, we add the zeros. We're not really adding zeros. Well, here what we're going to do is we're going to move the decimal. And we're not really moving the decimal. We are actually doing what I just did up here, shifting it. But watch what happens when I do this. So I'm going to go 3.4. So I'm going to do the same thing, start the same way, except this time, I got to make my decimal better. This time, I want you to think to yourself, I'm multiplying, right? So there I am, I'm multiplying. Do I want my number to get bigger or smaller? You want your number to get bigger. So I need to move the decimal, but I want to make sure my number's getting bigger when I do it. Because if you look this way, I moved all the numbers this way. But as I move the numbers this way, it almost looks like the decimal's moving backwards. And that's what's going to happen here. So I'm actually going to move the decimal this way. Watch what happens when I move it. So I have 3.4. When I move it, now I have 34. That's the way I want to go. Notice I didn't draw anything. I didn't write anything. I'm just doing it in my head. I'm thinking, I'm going to move it this way. And yep, that gives me 34. So that's the way I want to go. So instead of making all this and drawing all this, we're actually going to move the decimal. And it's going to be a lot nicer. Watch. So I know 3 times. There's my exponent's 3. So I'm still making 3 shifts. That's what I'm doing. I'm not adding 0. I'm making shifts. Adding 0 is the trick here. I'm making shifts. I'm making 3 shifts. So I'm going to shift the decimal. 1, 2, 3, new decimal. Notice when I shifted, I made the little shifts big. Don't make them too small, because then you're going to you're not going to be able to figure out how many zeros you're going to need. So I made them pretty small, or I made them pretty big. What goes in these empty spots here? We say they're like egg cartons. You got to fill the egg cartons. You got to put the zeros in them. Okay, so then you have that. Now, again, all I ask you to do is rewrite it. You never leave this like this, 3, 4, 0, 0. Do I need the decimal in the end? No, because there's no numbers behind it, so the decimal can drop off, and I just put my comma. Okay, so that's kind of how this works. Same problem. We have the decimal shift. We have the place value shift. That's what's really going on up here. And then we have the shortcut. So you can probably tell which one you like a lot better. This one's a lot nicer, a lot less messy. Okay. So now we're going to try another one. Let's go 3.694 times 10 to the second power. So again, the first thing we know is, since we're multiplying by a power of 10, we know this digit, these digits are going to stay the same. So I know my problem is going to have the same numbers in it, 3.694. So I just rewrite the whole thing. Now I know I'm multiplying. So I know I want my decimal to move. Let's see. If I go this way, that's 0.3. I don't want that. I'm multiplying. I want to get bigger. So I'm going to go this way. That's 36. That's the way I want to go. So I kind of established where I want to go. Now I know, okay, how many shifts do I have to make? So I'm going to go look at my exponent. I'm going to make 2 shifts because I have 100. And if it was just a normal 100, you would say, okay, there's the 2 zeros. Zeros mean shifts. So I'm going to shift twice. 1, 2, new decimal. So now I have my new decimal, so I'm going to rewrite it. 369.4. So this time I didn't need to have any extra zeros. This time I kind of relocated the decimal. Again, the decimal truly technically doesn't move. What you're doing is what you did up here. It's just a lot nicer to do down here. You're shifting the numbers up the place value. As you shift the numbers up, it looks like the decimal's moving, but it's technically not. Let's do another one. Let's do 7.84 times 10 to the 5th power. Let's go pretty big here. Okay. So if we have this kind of problem, again, what do? First thing you're going to do is rewrite the digits. Rewrite the digits. We know we have a power of 10 number, so it's going to be the same digits. Now you have to identify. I'm multiplying. So I'm underline my multiply sign, and I'm going to know which way do I go? Yep, I go this way. because I want that 7.8. If I go once, it'd be 78. That's the way I want to go. So now I have to figure out, okay, I have 5 shifts. 1, and make sure when you do it, get up into the numbers so that way you can see that's where he's at. 2, now make decently big ones. 3, 4, 5, new decimal. And again, how many zeros do you need? I need to fill my holes. 1, 2, 3. So I fill my holes like that, and then I rewrite my number. 784 000, and I put my comma in. Just like that. Okay? So you're going to have some problems like this. So let's see if I can do this one for you. 10, and then I'm going to put a box up here, equals, and I'm going to do 0.056. Oh, I did that wrong. I'm sorry. This is going to be a multiply sign. My fault. That's multiply sign. Equals 560. Well, now you got to figure out, well, how many times did I shift? So now you got to figure out, well, I know I want this number. That's the number I want. How many times did you move the decimal to do that? So what I'm going to do here is I'm just going to rewrite this number, 056, and you're going to rewrite it until you have 1 extra 0. 1 shift, 2 shift, 3 shift, 4 shift. That's where the extra 0 would be. So I'm going to rewrite it. I'm just going to double check. Because this 0 is now in front, I don't need it. Technically, it's this. I don't need that 0. So then if I have it, how many shifts did I make? I made 4 shifts, so the exponent would be 4. Okay? What if I had 10 to the, let's go another blank, times 0.371 equals, and let's say 371. Let's just say it equals 371. So how many shifts would I need? Again, rewrite it. 1, 2, 3. Notice there's no zeros. So what would I have? I'd have 371, and I'd have an exponent of 3. Okay? So this is technically what you're doing. You're shifting the place values. But the shortcut kind of helps us by moving the decimal. Again, you don't move the decimal technically. You're shifting them, but we allow you to show that because it's way easier to show your work. All right, guys, hope this video helps.